will try to interface some sort of sensors and actuators module. Okay, so that would be about this session. So if you have any queries from the last session, just let me know. Otherwise, we'll start and move forward with this session. Are there any queries?
No, sir. We can start, sir.
Okay, so we'll start with this particular session now. Let me just share my screen. Okay, so I guess you can see the screen now.
Yes, sir.
Are you?
It is visible.
Yeah. So this is what we were doing earlier. Like the code we wrote is just to toggle the voltage on pin number 6 and 4. Okay. So now what we will do, we will try to like this digital IO functionality we saw. Now we will see some analog input also. So let me just get a potentiometer. So this is our basic potentiometer. Okay, so we all know that basically a potentiometer resistance, you can see I can change here. Let's say 1 kilo ohm resistance I will have. Then if I rotate this knob, the resistance will increase. Okay, so what I will do, I will connect the two ends. 1 second. Let me connect one end to the ground. Okay, and this end to VCC 5 volt, and this end what I will do, I will connect it to pin number A0. Okay, so now we will be able to read this value. Okay, so let us just write some codes for it. So again, we are not using anything digital here, so let me delete this. So Boolean X is also not required now. So this part, let me just delete. Okay, so the delay will give 1 second in this case. Okay, now the command that I am going to write is okay, let me just have one integer, int x. So x is equals to analog read A0. Okay, so it will read the value of A0 pin, which would be the voltage that we are getting here. Okay, so we all know the working of the potentiometer. So whatever voltage is across this variable resistance will be read on this particular pin, and that we will try to convert to a normal voltage and see what voltage we are getting. Okay, so we are reading that particular value here. Okay, so let us just simulate it. Okay, so now, okay, oh, we didn't put anything on serial. 1 second. So this would be serial dot print ln. Now this command is for printing on the serial X. Let me just run it. So what did I miss? Okay, see, okay, I spelled it wrong. You see, I'm getting some value now. Let me just try to rotate it. And you can see the value change. Okay, but right now what we are getting is these numbers. So basically what we'll do, we'll apply unitary method here, and we will try to understand, convert it to a voltage, because I know that this voltage is fluctuating from 0 to 5 volt, because we have given that only 5 volt. Okay, so what I will do, I will add some code in my programming. Unitary method will apply. Let's say x is equals to, we know that okay, if you understand it like this, So we know that 1023 is equals to 5 volt. Okay, so we can understand that x volt would be equal to 5 multiplied by x divided by 1023. So this formula we will try to put. So let me just put 5 volt multiplied by x divided by 1023. Okay. This should give us a voltage value. You see, we are getting 4 volts right now. Let me change it. Okay, so this is integer. One thing is okay. This is integer. We need a floating number because integer will only give us. What happened? Integer will give us integer value only, and this voltage will be on. Uh, as you can see, it would be on that also decimal value also. Okay, so these are the codes. Let me just make this float. So float is our decimal numbers. You see, we are getting 5 volt now. Okay, now let me just try to move it and see. Now we are getting the data of voltage 0 to proper 5 volt we are getting. So this is a normal analog input reading that we have done. So now what we will do, we will use this and now based on this we will try to let's say glow some LED. I'll take one RGB LED. Okay, so we know that this is ground. I can just connect it to this one. Let this one be connected like that. 1 second. Okay, so this is connected here, and the red I am connecting to pin number 1. Blue I am connecting to pin number 1 here, 0 1, and then I will connect the next one here to pin number 3. Sorry. Okay, so in my programming what I will do, so let's say if voltage is in between 5 to let's say 4 volt, I want blue color LED to glow. Now blue is which one? This is green, this is blue. So blue is connected to pin number 1. Okay, so let me just initially give these LEDs as output pins. Number 0 output. Pin number 0, 1, and 2. Okay, so I'll put one if statement. If x is if x is greater than 4 volt and less than sorry, less than 5 volts, less than equal to actually. So if it is in this range, I want digital right number what pin number 1 to be high. So pin number 1 is basically this one, and this is our blue. So in this range, I want blue LED to glow, okay, and all others to be off. So what I will do, I will add those commands also here. Okay, so digital write pin number 0 as low. Only one of them should be high, and pin number 2 also low. Okay, so this is a statement. Then I will put in another statement similar to this. Copy. There are three cases, like if it is in between, let's say 4 to 2 volts, then I want which one to be high? Let's say this one, the red one, which is connected to 0. So 0 should be high, 1 should be low, and 2 should be also low. Okay, and the next range is 2 to 0. Here I want the third one, like green one, to be on, which is connected to pin number 2. So the pin number 2, 0 is low and 1 is also low. So this is what I want. Okay, so this is what we have given. Let us just simulate it. Okay, so you see right now what is happening. Uh,
Sir, we have to connect
so if I change it,
the resistor, the bulb, the LED.
what's up?
So actually, we have to connect the resistor. Otherwise, because it seems that the current is large, so the LED will get burst, damaged.
That should not be the case, sir. But anyway, we
So we
can
have to
do
connect
that.
the resistor. So we have to connect the resistor.
No, I get your point, sir. I get your point. You can do that. No
Because
problem.
if you put our mouse there, I think it will show it. Current is large current, I think.
I doubt. So. Anyway, we'll put resistance also now.
Can the resistor be ground? Sorry. Okay, thank you.
One sec.
Even we can connect it on the ground. Where remote.
Okay. So let us just start the simulation now. Okay. So this is blue right now. If we make it, you see right now it's not changing. So we have done something logical error is here. It's not about the resistance. Some logical error is there in our program. So the value, it's not changing at all the color. Okay. So if it is 0 to 2, still some error is here. Okay. What is the error? 0, 1, 2. Okay. So in this case, 0 is high, 1 is low, and 2 is low. But is in this case, 1 is high, 0 and 2 are low.
I think we got. I think we got to include the else
What's it?
command. If else, whether you have to use else command. If else,
No, so that is not the issue.
I think it is not needed in embedded coding.
We can use only if also, sir. It's not required to put both if and else. One more issue could be there. Let's just work out on that. This is red. So we're using 567 now. 7 pin number. 6 and 7 pin low. And let's get 6 to be high. 5 and 7 below. Let's get 7 to be high. 5 and 6 to be low. So now it is running, but only one color is coming out. This is the 7th case. That means it is not going into these two range. One case is working, but other cases are not. So anyway, we can look at later on.
So I think
Yes, sir.
for the second condition of 2 to 3.5, I think voltage is low, so that's why the LED is not glowing. So 2.5 to 3.5, actually that indicates the
No,
output
sir. We are
voltage.
not transferring this voltage. The voltage that this LED
I
is
think that
getting is 5 volt only. That is
because
not
of high, because of
that is
high
not,
condition,
yes, because
this is
yeah,
because
that
high
is high
condition.
condition, which it will be
Yes,
getting
yes,
5 volt only.
yes, yes.
This voltage we are not transferring at all. So this is
Uh,
we are just measuring and comparing it, nothing else.
yes.
Anyway, we can do that part later on.
Yes. 2.5 to 3.5, 2 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 to
Stop it. So a simple experiment could be just use a
So
normal
that
LED.
may be, I think that may be, since we are operating fast, that may be.
Yes, sir. This let me put down pin number 6. Okay, so pin number 6 only we will be checking. Okay, if x is greater than, let's say, 3, then digital pin number 6 is what we are using. Okay, else in this case I would want it to be this low. So if it is greater than 3.3, less than 3, it what is here? Okay, one thing we missed here. There is one extra. Okay, so if it is less than 3.5, it should glow. Yeah, you see, the system is maybe a bit slow here, but I guess this one is working now because we have this delay. Okay, so this delay also should be at end. So that is why we are seeing some delay. Let me just from here paste here. You see it is on. So now the response is better. Okay, so this is a simple process. You can just see based on some input value, you did some algorithm running and then you gave an output. So this is a basic embedded system that we will be using. Okay, so let us just try to now complicate things a little now. Okay, so let me just delete this. Okay, not the delay. Then delete this part. Everything else will be common. Here, delete this, and this. Now we will try to take some sensor. Let's say we take light sensor. This is a photoelectric resistor. Now this would act as our one second. So we have ultrasonic sensor also. Yeah, you can see, and we have this also. Okay, so this one is what we'll be using. So we have 4 pins: VCC, ground, and your trigger and eco pin. Okay, so let me just give it connections quickly. Then I will explain you how this particular system is working. Okay, so now we need to connect these two. And I will take it here. Trigger is pin number 10. Okay, so this is a digital signal. I'll explain you the working of the system. So let me just connect the system once. This is connected here like that. Okay, so now let me show you how this thing is working. This one. Okay, so ultrasonic sensor, like you can see, this one is what we are using. HCSR04. It has again 4 pin. Okay, so now the working is like we have two blasters, as you can see here in the image. One will act as a transmitter, one will act as a receiver. So we will send a signal which will go in the environment, hit an obstacle, and come back. Now the echo will receive this. So the distance it has traveled is roughly x. If this distance is x, so it traveled 2x. Now 2x distance it traveled, the time period we know at what time we launched and at what time we received. So that time difference we can calculate, and then we know we can calculate the distance using speed and time distance formula. Okay, so the simple mathematics is that. So that is how it is working. So this is what we will do. We have a simple program also, like I'll explain you. We have a trigger pin, we have a echo pin. So trigger pin is output because it's transmitter, echo pin is input because it is receiver. Then we will give a high signal on the triggers. So we'll send a signal, then for 1 millisecond, then we will make it low. Then this pulse in function will actually help us receive, basically measure the time period of some particular signal. So that is what we have done. Echo pin, it will measure for high signals, for how long this was high. Okay, and then we'll apply the basic formula and we'll have the distance. So I have this program with me. Let me just get it. Mm, okay, so this program, same program, I will copy paste here. So just to show you that yes, this will work exactly. So let me just copy here. These are the codes. Let me just run it now. You can see distance. 1 second. So this is the object, you see. If I increase the distance, why is it not changing? Oh, okay. So I made a mistake. Pin number 9 and 10 is what we are using, and we are using 10 and 11. That was a mistake. And the trigger is this one. Trigger is 10 and echo is 11. So that is why we were having the issue. Now you can see 190 centimeters is showing. So if I move it near, you can see that it is getting almost zero. Now at this range, it is giving some false value. So because it has a minimum and a maximum range, we have crossed that part. That is why it was showing us this. Now this also is out of range. This also is out of range. So they have actually given you the area where this will work. So within this, you can easily check if it is working properly or not. Okay, so this is just a simulation. In real world also, we can just try to put some object in front of it and it will keep on working like that. Okay, so this was our basic program for ultrasonic sensor. Any doubts in this? Are there any doubts in this?
For real-time implementation, if you is it possible to embed the same program in the
Yeah.
board? No.
So yes, you see this program I copied from the Arduino ID only. This is a
Okay.
real program, and the same program I just copied and pasted there. So this anyway, I use this program in my other trainings, where I
Oh.
burn this program in a real board and connect the sensor, and then I move an object in front of it. So that can, so the same program will work here. So this is Arduino ID, just for your reference. So I don't have an Arduino board right now with me, otherwise I would have shown you this also. Okay, so you can see if I'm moving this object, it is changing the distance. Okay, so this is how
So for the
our
final hardware implementation, we can check it using these two.
same exact. So you note
Yes.
down the circuit connections, you note down this your program, and the same thing will work on hardware also.
Yes.
Okay, so it will work exactly like it is working here also. Okay, only difference that you might see, like right now, how if I make it, if I put this object out of the range, it is giving like 334 centimeter, which is some sort of saturation I am imagining here. If I give some random value like 200, 300, it will keep on fluctuating that way. So that would be the only difference in real and this. Otherwise, this is pretty fine. Okay, any further doubts?
Sir, do we have Raspberry Pi board and embed board and
No.
some other boards also?
Here we have Uno only, ma'am. What do you know?
Arduino. Yes.
Yes. If you are looking to work on some ARM board, you can use Keel software as simulator.
Yes, sir.
Keel software is there that
Yes,
can be used in simulator mode. So you will have access to all the IO pin in simulation only. You won't need your real board there. But this will give you actually a better experience because there you will just see some let's say if I'm sending some on off signal, toggle signal on a digital pin. So you will see just a checkbox and it will be checked, unchecked. It will keep on fluctuating like that. So
right.
here you have a better graphical experience. So this is a better learning thing. But yes, you can obviously use that. Even ARM embed platform is there online, which is again online only. So there
Yes.
also some sort of simulation you can do. Okay.
Yes.
So, yeah, but only thing is that this part, this graphical part will not be there. This part will be there. This coding part would be there, and you will have a serial monitor too, and you will not see this part, graphical part. But yes, obviously that will give you access to most of the ARM microcontroller, which you might have in your lab.
Yes.
Okay, so this is one thing. Now let us just look what all sensors we have. Okay, so okay, so we have all these diode, photoresistor. Let us just try to use photoresistors. So photoresistor is basically your resistance only, and this value will change based upon the light that falls over it. So what I will do, okay, so let me just connect it. Okay, so what I will do, I will just connect it to 5 volt and ground. Okay, now what I will do, I will just take this pin. No, no, not like this. Oh, sorry. Let me take a resistance now. Okay, let it be 1 kilo ohm only. Okay, so it is like a potentiometer circuit I was trying to make. So we have given this, and then whatever voltage is there, we will read here. I'm not sure if my circuit is correct, but anyway, let us just try to work. So let me just say, delete this. We don't need any digital pin here. Okay. Then all this is not required. We will just have one integer I and float x equals to n read a0, then serial dot print ln x. Obviously it would be voltage, so let us apply the same formula we did earlier. 5 multiplied by x divided by 1023. Okay, my circuit is not correct. Yeah. Okay, now we are getting something. So if I increase it, now you can see. Okay, so this basically is a potentiometer circuit only that we have done. So you can consider it as potentiometer. We had 3-terminal potentiometer, and these are the 3 terminals. And only thing, instead of rotating the knob, I am increasing the light intensity over it, and you can see the light intensity increases and the voltage across it basically decreases, because the resistance decreases, and obviously with resistance our voltage drop across it will decrease. So it is a resistance only, which is just variable based upon input value of light intensity falling over it. So this is the basic program. You can just now, based on this also, I can put in some LED to work. Let us just see if we have something. Let's say a buzzer. We have a buzzer. Okay, so this buzzer is positive. Let me just connect it to pin number 3. This is our ground. Yes, let me just connect it somewhere. We have another ground here also. Okay, so in the program, what I will do, uh, if x is greater than 2.5. And what I want digital write, and it is connected to pin number 3 to be high. Else digital write be okay. So let me just define pin number 3 as output also. Node 3 output. Let me just see. I'm not sure if you can hear the buzzer sound. Can you hear the buzzer sound?
No, sir.
1 second.
Yes, sir.
Can you hear it now?
Now audible, sir. Yes, sir.
Okay, so this is the buzzer sound, and right now you can see it is greater than 2.5, like 4.9, and hence it is it is on. Let me just move it. You see now it is off. On again, and as soon as we crosses 2.5, it is off again. So this is again a system we can have. Like it could be an ambient sensor in your system. Like if you have, like you can put such sort of system in your home that if the light is falling below some particular level, switch on a light. Instead of a buzzer, you can put in a light. So that sort of system you can put. Okay. So this is one thing. Let me just stop the simulation. Any doubts on this? Are there
No,
any
sir.
doubts on this? Okay.
No, sir.
Okay, so now I'll show you relay also, how relay works. So let me just delete this, and this. Okay, so let us just get a relay. Okay. Mm, I guess we don't have that relay which we were looking for. It's this relay. This is a relay module. I don't understand what it is. 1 second, anyway, just. Okay, so this is terminal 1, terminal 2. We have all the terminals here. Okay, now let us just look at it. Terminal 1, terminal 2, 7, 5. Okay. Photodiode. We also have a photodiode which will act something similar in the ambient light sensor. We have a tilt switch also. We have a gas sensor also. We have keypads, switches, LEDs, bulbs. Okay, so there are many things that we can try. Okay, a normal DC motor is also there. Okay, so this also we can try. Like if I can put it to ground here. Let's connect it to pin number. Let's see this and write a simple code, pin number 4. So this will not equals, so this should write for high. Then we will add a delay of, let's say, 2000. Then make it low again. And then again delay of 2000. What mistake we did? Okay. You can see it is on now for 2 seconds, off now for 2 seconds. So you see sort of a blinky program we have given here. Okay, so it is on, off, on, off for 2 seconds. It is switching on and switching off. So again, we can have this based on any of our input device, like the photoresistors we have. Okay. So even from here, you can get the Eagle file also here and get the circuit working. You can share this with people over email also here. Okay, and even you can download this code here. You see, this code has been downloading now. Okay, so this code again same as it is. From here you can download. You see, this was the basic code. Then if you have a debugger is also there, which you can use. How it works: add breakpoints and click also. Basically, to add breakpoints, we can add some breakpoints and try to see our values on that particular point, which anyway we don't need right now. Delete it. Okay, so you can even print it. These are some libraries that are already included. Okay, like SPI libraries there, servo libraries there, keypad library, LCD library. All these libraries are already installed in here for you, and that is why all these devices are also available. Okay, so this here is some sort of annotation. You can add something. Okay, we need to start this first. Okay, so we can just put in here and add some notes also for documentation purpose. Okay, we can flip our circuit also if you want. Select the parameter and rotate it. Okay, so that is up to you. Okay, so there are many things here. Obviously, we will not be able to cover all. Even we have a potato and a lemon battery here. Okay. Okay, let us just look what all components are there. Okay. So this photo slide diode also works same. Ambient light sensor is also something similar. IR is again for IR detection, or again distance finding also can be done with IR. PIR is basically your movement detection. Then we have a tilt sensor. So then we have a tilt 4-pin sensor. A temperature sensor is also here. Gas sensor. This one might be what, MQ. I'm not sure which sensor it is, but MQ sensors are there. Okay, then different dip switches and all. So if you have any doubt, you can let me know. Any doubts up till now? Are there any doubts?
No, sir.
So
However,
let's.
it is
Yes,
found that we have to develop
Exactly, sir. Now you have seen
coding.
how this system works, and
So we got to develop
yeah.
coding skill. So I think we got
Uh,
to develop some coding skill. However,
Sir, for
really it is
Arduino,
very useful.
you don't need much coding skill. It
Uh,
is very simple enough to work. Like even for most of these basic components, now you will find ready-made code online. So the things that you have to remember is like we have a void function, then we have a loop function. So whatever we have to do in basically whatever we have to run once only will go into setup. Then whatever we have to run continuously will go under loop. Like here, what I'm doing, I am defining my pin number 4 as output pin. So this obviously we have to do once only. We don't have to do it multiple time in our programming. Then in the loop, what we are doing, we are making it high, then giving it some delay, then making it low and giving it some delay. So it is sort of a square wave we are giving it with a complete time cycle of 4 seconds. Okay, so that also we saw here also. Like it will be on for 2 seconds. You see the rotation here, then stop for 2 seconds, then again rotation for 2 seconds and stop for 2 seconds. So this is a square wave we are giving here. Okay, so it is actually very simple, not too complicated. You might just need a day or two to
yes,
understand it.
some understanding is required.
Yes, so that would mean that maybe a day or two you will need to come up to this speed. Okay, so if there are no doubts, maybe we can stop for stop the session.
Sir, any assignment for today's have you given, sir?
No, yes, no, any assignment I have not given. Okay,
I'm is always worrying about
yeah.
assignments.
Ma'am is very
So,
curious about the assignments.
so any
It's like
okay, so I'll give you this
we are all,
assignment.
I think we are all
You
not
have to
students.
you have to integrate this temperature sensor with this Arduino.
Okay, sir.
Okay, so you can write down the part number TMP 36. Okay, it's very simple enough exercise. You just have to give the connections. First, see what exactly this device is and what these 3 pins are. Like if I put it here, you can see that it is power, which will be VCC. This is ground, and this is my V out. Now this is which pin, analog pin, digital pin, that you have to check, and accordingly you have to write a very simple program. If it is analog, then it is simple enough. You will just read it, and again you will be apply and you will be just putting it on the serial. If it is digital, then you have to put in some sort of programming to read that digital data that you have to check. So you have that part number TMP36. Just Google it and learn about it, and then you have to make this basically a temperature monitoring system. Okay, I guess that should be okay for the assignment.
Yes.
Okay, so
Like
yes,
we find some difficulties. We find some difficulty in loading.
what what's up?
Yeah, we find some difficulty in loading because we are using only laptop. We find
So,
some difficulty in loading this.
sir, I am also actually using it on laptop only. So I am not very sure what is creating that issue. You can maybe try another laptop or another browser, and maybe connect it to your mobile's hotspot and see if that internet connection change is helping you out. That all you can check. Neha ma'am, we can stop for the stop the session, I guess.
One second, sir.
No, attendance link shows that it already been filled like that. It shows attendance
Oh, one
link.
second. Just a second.